Alright guys, so this is homework number 2, answer key. So we're going to look at some example functions. We've got some inputs. 2 becomes 5, 5 becomes 8, 7 becomes 10, and -1 becomes 2. And we're going to try to figure out what the pattern is to go from the input to the output. And so this might have taken a while to figure out, but it looks like to me the pattern is add 3. If you take 2 and you add 3, you get 5. 5 plus 3 is 8. 7 plus 3 is 10. And -1 plus 3 is 2. So now, if we want to write that, or, well, let's save the rule for part C, I guess. But since the pattern is add 3, when we plug in 4, we add 3, we get 7. When we plug in -10, we add 3, we get -7. Now, writing this rule algebraically, it looks like whatever we plug into the function x, we get out x, the number we plugged in, plus 3. For the next problem, it's the opposite. Instead of giving us a pattern and finding the rule, they give us the rule. G of x equals 4x minus 5. So for part A, it looks like this should have read G and G here, but I hope that didn't throw anyone off. It's a small typo. So we want to find G of 6 in part A. Since 6 is the input, we plug 6 in for x. And then we simplify the right-hand side, giving us 4 times 6 is 24, minus 5, g of 6 is 19. For part B, pretty similar question, but we're trying to find g of -7. So since -7 is our input, we're going to plug that in for x in the equation. That becomes g of -7 equals 4 times -7 minus 5. G of -7 equals -28 minus 5. G of -7 gives us an output of -33. Next up, oh man, it looks like I kept doing this with the letters, but let h of x equal this function, 2x squared minus 6x plus 1, and we're supposed to find h of 4. So matching things up, 4 is the input. We plug 4 in for all of the x values. And this one's pretty cool because we have the x values in 2 different spots. I actually got a lot of questions about this situation in class today, where we had multiplication, parentheses, and exponents. So we go to our order of operations, PEMDAS. We look inside the parentheses. Here I see just 4 and 4, so the parentheses are fully simplified. Next comes the exponents. So before we multiply by this 2, we have to do the 4 squared. That gives us h of 4 equals 2 times 16 minus 6 times 4 plus 1. H of 4 equals 32 minus 24 plus 1. H of 4 equals 8 plus 1. H of 4 equals 9. Next up, we have let f of x equal 4x plus 2. If f of a equals 30, then what is the value of a? And this is the first one of the problems from the last part of class where instead of giving us the input, we know the number for the output. So they give us that the input is a. So the way that I like to read these problems when they give us the input and we're trying to find the output is when we input a into the rule, the output is 30. And that creates an algebraic equation that we can solve using inverse operations. So we subtract 2 on both sides. We get 4a equals 28. Divide by 4 on both sides. A equals 7. And this is a nice problem to check. So when we input a into the function, if a is 7, when we input 7 into the function, it gives us the correct output, 30, which is what we wanted. So just to be clear, this was the answer. And this was an optional check, but I think in this case it was nice to do. For problem number 5, we've got g of x equals 3x minus 5. If g of b equals -17, what is the value of b? So this is one where they said the input is b, and the output is -17. So we'll plug b into our problem. 3, plugging b in for our input, minus 5, equals an output of -17. We add 5 on both sides. 3b equals -12. We divide by 3 on both sides. B equals -4. if h of x equals 4x minus 6, then find the value of z such that h of z equals 14. You guys are going to have to do this one without the answer key. Maybe I'll check it tomorrow. Good luck. And finally, for problem number 7, we've got one of these literal equations with all these variables. So I noticed in the last homework assignment, a lot of people plugged in numbers for A, B, C, and D. And maybe it was confusing because there's a part A, a part B, a part C for before. But when you're solving for x in terms of these letters, you want to leave them as letters. Okay, so we need to solve this equation for x. So thinking about what we have to get rid of first, A, B, 1, or C, since the C is furthest away, let's start by getting rid of the C. So we'll multiply by C on both sides. Going back to blue, that gives us C's canceling out. AX over B minus 1 equals C times D. Just like we talked about in class today, we can use the commutative property to write that as C times D. Next up, in solving for x, the 1 is the furthest away, so I'll add 1 on both sides. We get AX over B equals CD plus 1. Next up, the B is the furthest away, so we'll multiply by B on both sides. And just like you guys noticed in class, we'll have to put parentheses to show that we're distributing to the whole side. So we get AX equals B times C times D, and then plus 1 times B is B. Finally, to solve for x, we divide by A on both sides of the equation. We get A's canceling out, x equals B, C, D plus B all over A. Great, I hope that was helpful. See you guys tomorrow.